Hi everyone, welcome again to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. This channel is also intended to those uh, who are doing their online classes out there. Hello, and also those who are answering their modules. This will help you understand more and build the concept in your lessons in mathematics. So I hope you'll not forget to subscribe my channel and share this channel to your friends so that at least you can help them improve their performance in mathematics. So are you ready in our next video discussion? I guess you're all ready. Our topic for today or in this video discussion will be about measures of variations or measures of variability. Again, measures of variability and measures of um, what I mean, measures of variability and measures of dispersion, they are just the same. So again, as I have said, our topic will be related to measures of variability, but this time we will focus on the ungrouped data. So the measures of variability, we have the objectives so that we will be guided on it in our discussion. So our first objective is we're going to understand the different measures of variability. Second objective for this video discussion is to determine the range, variance, quartile deviation. Maybe we will not include the quartile deviation. We will just have it the standard deviation for ungrouped data. So our discussion for today will be about or will focus on the ungrouped data. So to start it, the purpose of measures of variability, consider what we know if we know that the mean test score was 75. So single score to represent the spread of the entire distribution of scores. So in short, the purpose of measuring or measuring the variability or dispersion from the word itself, dispersion, is we are going to identify and describe the spread of our data. How is our data being spread or distributed equally or normally? So that's how we, or that's one of the purposes or significance of learning this lesson in the measures of variability. We will talk more of that later. So I want you to be guided with the types of measures or statistical tools under the measures of variability. We have the range, we have the interquartile range, as I mentioned last or in our previous video discussion. We have the semi-interquartile range, the variance, and standard deviation. So for this topic or video discussion, we will highlight the discussion on the measures of variability in the range, variance, and of course, the standard deviation. So I want you to focus on the three measures of variability. Again, measures of variability is also known as measures of variation or measures of dispersion. So I hope you'll be able to recognize the other term for variability. So now let's define measures of variability. As you can see there, measures of variability tell the spread. It will tell us the spread of the frequency distribution. How is the observations or our distribution being spread? So that's the measures of variability will tell us also how widely the observations are spread out around the measure of central tendency, as you can see there. This one. Okay, so the most commonly used measures of spread are the variance and the standard deviation. So in the measures of variability, again, it measures the spread of the frequency distribution. It tells us also how widely the data being spread or the mean score is being spread. So there are two common measurements used here in variability. We have the variance and standard deviation as I highlighted here on the screen. So the measures of spread increases in value with greater variation on the variable. So the greater the variation, the greater or the value of the spread will also increase. So please do not forget that one. The measures of spread equals 0 when there is no variation. So in short, when the measures of the spread or variation or spread is 0, then there is no variation at all. So I want you to take the note of that. We describe the measures of variability. So are you still there? I hope you can follow. So as I have said, the measures of variability for ungrouped data, we define the measures of variability in here as used to describe the spread or dispersion of data. Say with me spread. Okay, spread. Say with me again dispersion. Dispersion. So spread or dispersion, that refers to the measures of variability. So I hope you can follow. By using variability with measures of central tendency, of course, we need the measures of central tendency in order to solve or to measure the variability. So to continue, measures of variability for ungrouped data includes, I mentioned a while ago, the range, interquartile range, mean absolute deviation, variance, standard deviation, z-scores, coefficient of variation. So again, our discussion will focus only on range and variance and of course the standard deviation. So we will just focus our discussion in here for the measures of variability. So let's proceed to the next. Sorry. So now, let's start with the range. So the range is being defined as the difference between the highest and the lowest values. This is the simplest but the most unreliable measure of variability since it uses only two values in the distribution. So I want you to remember that one. Again, the range is the most unreliable measures of variability. Why? Because it uses only two values in the distribution. So when we say range, it is the difference between the highest score and then the lowest score or lowest values in a given set of data. So the formula in finding the range is equal to the highest value minus the lowest value, where R is your range, HB is your highest value, and LB is your lowest value. So I hope you can follow with the formula in getting the range. Example of getting the range, as you can see there for ungrouped data, we have the given set of data 76859477766. So in that case, and based on the given, to find the value of your range, you will just identify your highest score, which is 9. Subtract it to the lowest score, which you can see there as 4. So 9 minus 4 is equal to 5. Therefore, the range is 5. So easy, right? So this is how we get the range of ungrouped data. So now let's talk about the variance for ungrouped data. So the variance, as I have said a while ago, it will help us identify how or the behavior of our data or the mean score being spread in a given set of data. The variance will tell us its characteristics. So the quality or the behavior of our data or the mean score in our data is the variance rather. That is the use of the variance. Okay, so later I will highlight its uses, its advantages and disadvantages. So let's focus first on the formula, how to get the variance for ungrouped data. So the first thing I want you to take down note and do not forget the process. Step number 1, we have to find the mean. Okay, find the mean. Next is find the deviation from the mean. How to get the deviation from the mean? After getting the mean, you subtract it to the raw score that we have, or scores or data that we have. Mean minus the raw score. And after that, square the deviation. So what will be the result in here in the mean deviation? You just square it to find this one. That's the step number 3. Step number 4 is you are going to get the summation. In short, add all. Sum it up. Sum it up the square of the mean deviation. This one, the square of step number 3. You add them all, then you already get or following the step number 4, which is the sum of the square deviations rather. And after that, you tabulate the result. So to compute the variance, you can use this formula. Okay? So what are the things that we need? This one refers to the mean. X bar is the mean, X is the raw score. Summation means you add the square of the mean deviation. When I say mean deviation, you subtract the mean to the raw score. And N is the total number of data. So I want you to take the note of that. You can repeat this video discussion if you cannot or if you missed my description in the formula. So this is the formula used to find the variance of ungrouped data. So now let's go over with the standard deviation. Actually, class, the process of finding the standard deviation is to just square your variance and you already have your standard deviation. Take down note. After getting your variance, the value of your variance, you will just square it or get its square root rather, then you already have your standard deviation. So I hope you can follow that. So again, same as you notice the steps for finding the standard deviation, it's like the same, or it is the same rather, in getting the variance, the process of getting the variance. So first, calculate the average or the mean. After that, calculate the deviation. How to get the deviation or the mean deviation? Just minus the score minus the average. So score minus the average. Next is the square the deviation. After you get the deviation, then you square it, then you already have the step number 3. Step number 4, you sum it up, just like how we do it in getting the variance. So after that, divide this by the number of scores in your data, which is which can be obtained in the formula of getting the variance. Remember, and of course, as what I have said, this is the only thing that differs in getting the mean compared to, or if we compare it to getting the variance. In in getting the standard deviation, the process is the same in getting the variance. But the last part will matter because in getting the standard deviation, you will just get the square root of the variance. Then you have it, the standard deviation. So I hope you can follow with the process. Of course, we cannot appreciate it without applying it in an example. So let's have an example. So this is the formula. You're wondering why is it the formula is different, something like different. The d squared there, it's like, remember the formula that I mentioned a while ago, x minus x bar, then squared. You can replace it with that, the formula that we had a while ago. So S is the standard deviation, another symbol used for standard deviation. That's one, the square root of that. Okay, so later we will talk more about that one. Your D is, as what I have said, your D is the division from the mean. Your N is the number of items, how many data that we have. And your S is the standard deviation. Of course, your summation of D squared means the sum of squared deviation. So are you ready? Okay, I guess you are all ready to have the discussion or examples rather to apply the formula. Example is calculate the standard deviation of the given scores in an algebra quiz. We have the data set 18, 20, 22, 15, 16, 12, 17, 21, 10, and 19. So next, we will proceed to the next. Now, the first step that we're going to do is we have to find the mean. How to find the mean? You add them all, divide it by the number of items. So there are 10 of them. If you want to count it, you can count it. You may count it. So just to check if it's correct. And after you add them all, then you divide it by 10. So after that, you have it 170 divided by 10. That gives you 17. So our mean is 17. That's step number 1. Step number 2 is, again, we will construct a tables of values. In short, we will look for the division from the mean. This one, the D. How to get the division from the mean? As I have said, division from the mean, you will just subtract raw score minus the mean. The mean is 17. So 18 minus, this is the raw score, the X. 18 minus the mean, which is 17. The answer is 1. 20 minus 17, that gives you 3. Very good. 22 minus 17 is 5. 15 minus 17, negative 2. 16 minus 17, negative 1. 12 minus 17 is negative 5. 17 minus 17 is 0. 21 minus 17 is 4. 10 minus 17 is negative 7. 19 minus 17, the mean is 2. So this is how you get the deviation from the mean, or the mean deviation. So next, we will square them. So to square them, we will square the mean deviation. What I mean, the deviation from the mean, or your D. So once, let's continue. 1 squared is 1. 3 squared is 9. 5 squared is 25. Negative 2 quantity squared is 4. Negative quantity negative 1 squared is 1. Negative 5 quantity squared is 25. 0 squared is, of course, 0. 4 squared is 16. Negative 7 quantity, close quantity squared is 49. And 2 squared is 4. Then after that, this is how you get the square division. So after you get the square division, then you will add them all, sum it up, your D squared. This one for a while. I'll just highlight. You will just add them all. That's the meaning of summation. So to add them all, you have it 134 as your sum. Please take down note. Your this one, your numerator, this one is 134. You will just substitute this one in here. And of course, your n is, how many data do we have? Your n is 10. So over 10. So 10 must be substituted here. So in short, 134 divided by 10. So that's how you get it. Then get the square root of it to get your standard deviation. So please not forget. Remember, please remember this one, the summation, 134, and then your n is 10. Summation of d squared is 134 and your n is 10. So please not forget that one because later we will use it. Okay, so to find the variance, of course, sorry, to find the variance, you will just use the formula, this one, without square root. So summation of 134 divided by 10, then that is 13.4. 13.4 is your variance. Okay, do not forget. This is your variance. This is a symbol for variance. 13.4 is your variance. 13.4. So after getting your variance, what did I say a while ago? The last step in finding the standard deviation, just get the square root of the variance, and that is already your standard deviation. So square root of 1 at 13.4 is approximately 3.66. And 3.66 is your standard deviation. So I hope you can follow. So the variance again is 13.4. Very good. And of course, your standard deviation is the square root of your variance, which is square root of 13.4 is equal to, what I mean is approximately 3.66. Therefore, the 3.66 in here is your standard deviation. So I hope you can follow. Observe that the dispersion of a set of data is small if the values are closely clustered about their mean. That is a very important thing to know. And that it is large if the values are scattered widely about their mean. So do not forget that one. So I hope you'll be able to grasp the steps and memorize, and will be able to memorize after this video discussion about the steps in getting the variance and getting the standard deviation. So in short, class, you cannot get the standard deviation without computing your variance. Okay? So I hope you can follow. Now, to highlight the advantages and disadvantages of the measures of variability, always remember to increase our level of accuracy and sophistication further. It is very important that we try to include all the pieces of data in our calculation. That's why you should not manipulate the data, or else you are just fooling yourself or fooling the people, especially yourself. So this leads us to variance and standard deviation, which are based on the mean. Because the measures of variability will tell us the characteristics and behavior of the spread of your data, as I have mentioned a while ago. So here are some disadvantages and advantages of measures of dispersion. Do not be confused. If I say dispersion, I am also referring to variation or variability. They're just the same terms. So let's start with the range. Advantages, a reasonably good indicator because you can get it easily, but it's not reliable. Okay, so badly affected by the extreme values. Why? Because you are dealing with just the highest scores and the highest score and then the lowest score. That's why that's one of its disadvantages. Interquartile range, not affected by extreme values. That's its advantages. Often used with skewed data. So for its disadvantages, it does not tell you what happens beyond the quartiles. Okay, so that's the disadvantages of using the interquartile range. For the variance, the advantages for using the variance, it's a good measure. Okay, all values used. Wow. Used when data are fairly symmetrical. In short, in a normal distribution. The data is when the data is in a normal distribution, then variance is very reliable to use. So now, in the advantages of using the variance, mathematical properties not useful. They prefer the SD or the standard deviation. Not so good if data are strongly skewed. So that's one of its disadvantages for using the variance. So for the standard deviation, good measure, all values used, very good, and used when data are fairly symmetrical, in short, normal distribution or normal curve, can be used in mathematical calculations of other statistics. Yes, we use standard deviation to describe the dispersion or how spread our data is in the graph or in the normal distribution. Of course, the disadvantages of using standard deviation is not so good if the data are strongly skewed. In short, everything in here, the measures of variability or dispersions will be affected when the skewed is very strong. So maybe we'll have a separate discussion about how is strongly skewed being described. Okay, so I hope you'll be able to remember these properties or advantages and disadvantages of using the measures of dispersion. Now let's proceed to the next. A summary. Let's sum it up everything that we have learned for today or in this video discussion. The measures of variations, we have the measures range, variance, and standard deviation. For the range, it's the distance between the highest value and the lowest value, or sometimes it is represented by this symbol capital R. And for variance, it is the average of the squares of the distance that each value is from the mean. It is again, it describes what the distance of the squares of the average to the from the mean. So it is used, the symbols used to represent the variance are these symbols. So this one and then the two one. Okay, standard deviation is means square root of the variance, or it can be represented in this symbol, the sigma. Okay, so I hope you'll be able to remember these topics about the measures of variability. So that's it. We will end in here. So I hope you have learned something from this video discussion in the measures of variability. So in our next topic, we will talk about the measures of variability for grouped data. So I hope you'll be able to remember, and do not forget to subscribe my channel and share this one to your friends, especially those who are in need of this video discussion. So that's it. Always remember that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. Always remember also, math is fun. Thank you for listening.